Hello everyone, hello. It's very nice to be here in Redmond Channel 9 studio today and talk to this virtual audience all over the world. And my name is Lena. I'm a solutions architect. I'm working with lots of data, distributed systems, cloud, data science, high load, and all these things. I'm also a member of F Software Foundation, Board of Trustees, and you're very welcome to join because it offers you just benefits in the educational sense if you're a member, and you will be able to participate in some initiatives that F Software Foundation suggests you. For example, there was an F mentorship program announced, and it allows people to learn more about F and to work with world-known experts in F to be better in your skills. So join, everyone is welcome. So now I'm gonna jump straight to the topic because there are a lot of things I want to tell you, and we have just 45 minutes of time. And as an end goal of today's talk, I'm gonna show you how to build a cross-platform F solution to interact with a small Cassandra cluster that we're gonna build from scratch based on Docker. And to do that, we should do a couple of things first. We should understand what is Cassandra and why in the world we want to use it. Then we'll talk about the data model, sample data model for today's demo. And I'll show you how to create the Cassandra cluster from 3 nodes. And it will be based on Docker, so it will be modular, nice, and simple. And after that, we'll use F to connect to our cluster and to interact with what we've built. So I won't stop on the F syntax much because people before me have already done a very good job explaining it, and I have a couple of talks recorded that you can watch and see why F is awesome. And so we'll be able to focus on more complicated things and see how we can work with distributed systems and how we can use F to interact with it. So there we go, Cassandra. Cassandra is a very powerful distributed database. To be more specific, it is the NoSQL Calm family database that is AP from CAP theorem trade-off. That means that it is highly available and partition tolerant. Even though the C part is missing, it's still we can still tune the consistency per query basis. And I'll talk about it a little bit later. So that was just the 10,000 feet view on what Cassandra is. And now to the justification on why we want to use Cassandra. So today on the IT business market, a lot of practical major problems arise related to data processing, data modeling, data management, efficient data storages. And companies of any sort desire to have their business critical applications to be responsive 24 hours, 7 days a week. And users be able to interact with applications with low latency, and the cluster be able to scale out very fast and easy. And of course, to store all of the data. And Cassandra is a perfect fit for this. And even though Cassandra is written in Java, we can still work with it with our favorite programming language, F#. And there is an official .NET driver that we can use. And I'm going to use it for this demo. However, there are a lot of other alternative open source solutions that we can use to work with Cassandra from .NET. And it's up to you to explore them, but for this talk, I'm just gonna stick to the official one. And F# has pretty amazing features and infrastructure, so why not just use it to build our solutions and store our data in Cassandra? Distributed systems are hard, and Cassandra is like a distributed data storage. So here is the true quote from the Leslie Lamport. It says that distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. It's kind of true. And this guy made a big impact on the distributed systems theory and invented a lot of algorithms like vector clocks, faxes, and other things. So that's why I must tell you about important aspects of internal Cassandra architecture. And I think you'd love it because it's very much similar to the concepts of functional programming in a lot of ways. So first, Cassandra's nodes are formed in a cluster as a ring topology. So when the new data comes into the cluster, the hash partition key is calculated, and the cluster already knows on which node new data will come. So each node has its own responsibility for the hash range of the overall ring. So there is a primary range, which is calculated for the data entry, and there is a secondary range, which is calculated for the replica nodes. So when we have a replication factor more than 1, the data will go on its primary node and to the secondary nodes where the replicas will be stored. Cassandra is also a highly available system. It means that it is completely masterless. All nodes act as peers, and any node can be a coordinator. For example, if the request comes to the node number 3, and the request is to change some data that is stored on the node number 7, then if number 7 for some reason goes down, then node number 3 will be able to store the operation that should have happened with the data on the node number 7 in its hints table. And this is more to ensure the availability. And as soon as the node number 7 comes up again, restores, then node number 3 will execute this operation and make the state of the data consistent again. And even though Cassandra is a AP system, it doesn't mean that we cannot make our operations consistent. It means that we can tune the consistency for query basics. So you know your data and you know your queries. You know which of them require consistency and which of them can be much faster if we make the consistency lower than, for example, all. So the basic general rule for Cassandra's consistency is that if the write consistency level plus read consistency level is greater than number of replication factor, then your data will be consistent. And the important thing is that we can get our queries to execute very fast if we query by the partition key, which is important because all data with the same partition key within the same partition are stored together on the physical level. And speaking of that, on the physical level, Cassandra operates the SS tables. This is just the data files that are stored underneath. And when the write comes, then there is the commit log, which is the data structure, which is immutable and append only. It is stable and it is used for recovery if something goes wrong. And there is the mem table, which resides in memory. And all the operations that happen to data go to SS table, to mem table in the RAM, and to the commit log. And as soon as the mem table is full, it flushes on disk, and it creates a new SS table. And as soon as we have a lot of SS tables on disk, they are compacted together in one file that is bigger, but more efficient data storage. So you can also group your data into racks and data centers. Racks are for fault tolerance, and data centers are more for geographical optimizations. And now I'm going to talk about the efficient data modeling a little bit. So in relational databases, the goal of the primary key is to provide the uniqueness. In Cassandra, the primary key is mostly for two purposes, for the uniqueness and for the satisfaction of table queries. Therefore, the data modeling process differs from the one we are using in the relational world. When we work with relational database systems, We create tables for entities and for many-to-many relations, and we follow the rules of normalization. When we do this, we save the disk space, but we have a lot of joins that make the speed of our data queries much less efficient. In Cassandra, we denormalize the data, and we therefore have the tables that are very, very tuned for our queries. And when we build our data model in architecture, we first do the conceptual data model, which is the same for any type of database, relational, not relational. It just shows you the logical view of what you have, entities and relations between them. But then you write out all your query patterns that you have, and you see what you actually want to do with the data. And you tune the data tables so that you can query them by the partition key. There is no right or wrong. You just choose what is more important for you, the latency or the data storage. So let's take a look at the sample data model for today's demo. Here is a table. It has a couple of columns. It actually stores coffee shops. And here is the table that we are going to create in Cassandra using the CQL language, Cassandra query language. And as you see, it's really similar to SQL. Here we indicate that just columns, names, and types. And we see that the primary key is street and coffee shops. So we're going to query coffee shops by street. And the partition will be this way. The most efficient data storage will be by street. And coffee shop is also the clustering key. That means that we can query the data which is ordered by it. We can do ordering in Cassandra within the partition. So the data is practically stored on the physical level in one partition together, but within it we can order it by the clustering key. So if we look at the data inside, so in SS tables it will look like this. This is just a really small demonstration of it. All coffee shops under one partition are stored together. For example, look at the Mississippi Street. It stores 2 rows, and 1 row which was deleted because when I created the table, I made a mistake and I had to delete this row, and it's marked for deletion. It's still showing, but queries ignore it, and we can just work normally, not taking this into account, but finally it will be collected. And this is how the data storage works. And we're going to use Docker because it's a great container management tool, and I'll just show you how easy it is to work with it. So the next step is to basically create the Cassandra cluster using Docker, and after that we're going to create the F# solution to run some queries against it. Look at that. So here is the Docker quick start terminal. What I'm doing here is running the Docker command for creation of the Cassandra node number 1. I'm running docker run -- name Cassandra 1, and the type of the node is Cassandra. The next thing I'm doing is logging into the bash terminal of this node. It's docker exec -it, the name of the node, which is Cassandra-1, and the bash. And the next command I'm doing is node tool status. It just shows us which nodes are in the cluster right now and what state they have. They are up and in normal state. Now I am going to add the second node, and the command is pretty similar to the first that we created, and we just link the second node to the first node. It is very simple because they should be in one cluster, and it allows us to do this. And after that, we're just logging into the bash terminal and checking if we actually added this node. And now we should have 2 entries in our cluster. You see, there are 2 entries. One is up and in normal state, another is up and in joining state. You see UN and UG. Cool. We're just going to wait till it joins. Maybe we'll look at the kinematic UI. It is the UI for Docker. And here we see 2 nodes. We see Cassandra 1 and Cassandra 2. And you see it's joining. Oh, wow, okay, it's already in normal state. Let's recheck it in our Docker Quick Start terminal. Here we are. We have 2 nodes which are up, and we see their IP addresses. And everything that is left for us to do is to create the 3rd node. We're just going to copy the command and replace the Cassandra-2 to Cassandra-3. So we have 3 nodes for our normal cluster. And then just go into the Cassandra bash and check in the status of our cluster. Cool, we have 3 nodes. The 3rd one is still joining, but we're gonna just wait for it and type in the node tool status command again while it appears. It's very important to check if the nodes are actually up in normal state. As you see, they're all in one rack. There is rack 1 in the table because we didn't add more racks. And you can add some for fault tolerance. Boom, we have 3 nodes that are up in normal state. Okay, cool. So let's just memorize things that we did. We created the Docker container using the Docker run name and the name of your container, and the Cassandra, which is the type of it. For the 2nd and the 3rd node, we linked them to the existing nodes. So we just did Docker run, name of it, and the -- link. If you want to enter the bash terminal of the container, you just do docker exec -it, the name of your container, and bash. And in Cassandra, to see the node status, we do the cluster status, sorry. We do node tool status command. So we're going to the next step. Now we want to configure Cassandra nodes. We want to check that everything is working correctly, and we want to look at the configuration file, which is cassandra.yaml file. And to do this, I'm going to use a little trick. I'm going to open the 3 terminal windows, and I'm going to type in them at once. So I'm not going to repeat it 3 times for 3 nodes. So I'm doing that. Here is the 3 windows, and the first one is already the Docker Quick Start terminal. I'm just going to copy the command that opens it in all of the 3 windows, so they're in one state. And before I switch to the broadcasting mode, I should enter the Docker machine container for each of the machines that I have created. So for the Cassandra-1, I do bash. The same for the Cassandra-2 and Cassandra-3. Cool, we're almost there. And then I'm using iterm 2, and I go to the broadcast session input to all tabs. I'm doing that. So to edit the configuration, I need to add the Vim component because it's very simple to do it with Vim. So I'm updating the system, app-get update. It should be pretty fast. And the next thing I'm going to do is just download the Vim for all the 3 nodes. As you see, everything is happening at once and pretty nice. App-get install Vim. And after that, we're going to go to the Cassandra configuration directory where the cassandra.yaml file is stored and look into 4 settings that we should check. Cool. So we're navigating to vim /etc/cassandra/cassandra.yaml. And the first setting we're going to search for using /cluster name. It will be the name of our cluster. And in Cassandra, by default, it's test cluster, which I'm perfectly fine with because for me it's the test cluster. If you are working with a production system, you surely would need to rename this. The second thing is we're searching for the listen address. it should be equal to the IP address of the node. Here it is. So it's already set for our nodes because they see each other. It's absolutely fine. The next thing we're searching for is the RPC address. This is the node communication too. We just enter in RPC underscore address column, and here it is. So it's not quite right. It's just zeros. We need to replace it with the IP address. So the trick here is in Vim to enter the column R. Actually, we're going to switch from insert mode to the normal view. With column R space bang space host name -I. And that's going to output us the IP addresses of the nodes, and they are correct. So the next thing that's left for us to do is to place them all in the right position. Cool. The next thing we're searching for is seeds. Seeds are used for ensuring that the configuration changes propagate to all nodes good. So this is just a string that should store the IP addresses of nodes that the current node should be gossiping with. That means that it will broadcast the configuration changes promoted to other nodes and tell them about it. And it can be used across the data centers, for example. So basically, we should write the IP addresses of the nodes we want the current node to be gossiping with. It means to broadcast the changes to our string seeds. But one note is that for production clusters, we should not insert all of the nodes to this string. We should just choose the couple of them or just a few of them. Because it is a gossiping broadcasting protocol, you shouldn't indicate all of the nodes. But our cluster is very small, so it should be fine. Oh, and there is a small thing here. The default parameter was Cassandra for some of the nodes, so we should manually navigate to the windows where it was wrong and just replace it with the correct IP address of the first node that we have. Almost done. Cool. And now we are just broadcasting the input again and saving everything that we have changed. So we're doing the column W and Q. Cool. So what we've done basically is we looked into the main configuration file for Cassandra. It is a Cassandra YAML file. And we looked into 4 important parameters, which is like the minimum that we should check, which is the cluster name, listen address, RPC address, and seeds. And the next step is to open the necessary ports, which is the closest step that bring us the closest way to building the F# solution, so we can interact with the cluster already. Just go to the kinematic UI and check that the port number 9024 is set for each of the nodes. So I have all these nodes on my local host, so I should have different port numbers so I can connect to all of the nodes. Just make sure that there is some value. So don't forget to open the ports. And the next thing is the most exciting part of the talk is putting this all together and seeing how this works in the F# infrastructure. So now we're going to make the cross-platform F# solution to interact with the Cassandra cluster that we have successfully built already. That's just half of the battle. And now we're going to talk about the creation of the project. I'm going to use Project Scaffold, Packet, and Xamarin Studio on my Mac. So Project Scaffold is the very convenient way to create the cross-platform projects on any kind of system like Mac, Windows, Linux, anything else. You can basically just download the project from GitHub and build it, enter your name, rename it then, and open it with some editor like Visual Studio, Xamarin Studio, or VS Code, anything you prefer. And as a build manager, I'm going to use Packet. So let's just go and do this. I'm going to the website of Project Scaffold. I'm cloning the URL and opening the terminal. I'm cloning it. So after that, we should have the folder with all the components where we should have our dependencies file, where we should add the Cassandra driver dependency. And that's what we're going to do now. We're switching to the directory and seeing what's there. Here is the packet dependencies file, the exact file where what we need to change. Let's open it. It's in the folder. Let's just open it from the terminal. Cool. We'll look into this packet dependencies file, opening it, and we should enter the dependency that we need. By the way, Packet works with, it's not tying you to any kind of build tool like NuGet or something else that you used to work with. You can use any kind of build tool. You can use GitHub, you can use NuGet, anything you want. So we did that. And after that, we should build our project because it's new, or we can do packet install if we have already built it and to just update the dependencies. So we're building it. It is downloading the packet manager. And basically ready. We are entering the project name, just anything you want to name this project. And I'm going to skip all these additional steps with description, author, tags. You can enter it if you have time. Almost done. Cool. And now let's see what we have there. Let's just open this directory. Here it is. So here is the packages directory that we can open and look where is the things that we asked for. Cassandra driver, here it is, cool. So basically what we did is we cloned the project scaffold, we built it, we indicated some dependencies using packet. We opened this packet dependencies file, and to update the dependencies we used packet install. And now let's actually see how some code works with Cassandra and F#. I'm going to open the project using Xamarin Studio and show you what's there. Here is our project. Here is the file that we have edited, the packet dependencies file. And here is our code that I have prepared for the talk. The first thing we do is importing the driver. And here is an F# directive that we can actually use interactively. We're opening some libraries like the necessary system and Cassandra. And here is the function display line that will display our lines from the table, that exactly the same table that I've showed you on the slide. And the cluster value is connecting to our 3 nodes, and we should store it to interact with the cluster. The important thing is to connect to establish the session. So we're connecting to the existing key space, which is called system and waiting. Okay, here it is. We have a session established. To create the table, we should create first a key space, which is like a namespace for our project. So we're executing the query for creation of the key space. just create key space if it's not existing. And the replication factor ensures the safety of our data. And here is equal to 2 because we have 3 nodes, and 2 is pretty safe. So we're using this key space. Then we're just executing the script that creates the table, the same that on the slide. By the way, here we're using the simple strategy for replication because it's the local cluster. If we're going to use the Amazon or something else, we would have created the network topology. And now we are preparing the query for inserting some data to our table. This looks kind of like JDBC, but you can replace the values of the question marks with your own data and execute the statements. So we have added some data. Cool, and now we see that it's there. Here is the same data that we have talked about earlier. And it is stored inside the Cassandra. And now let's execute some more sophisticated query than just select from. Let's just query by the street so we can get data from one partition together, which is stored physically on the same level. And let's order them in the descending order. It should output us the Mississippi coffee shops, which are ordered the different way that they are ordered right now in the output. Cool. So here is the 2 strings, Mississippi coffee shops, tea house, and fresh pot. So it works. Cool. And now I just want to add a couple of things about the internal data storage. So it's very important because it may affect your mind when you think about how to create your tables or how to execute queries against your data. So what I'm going to do now is to navigate to one of the nodes that we have created in the Cassandra Docker cluster. And I'm going to look into what the as-a-stable files are actually looking like, so we can better understand the data and how it is stored, so we can build better F# solutions. I'm going to the GitHub page of the as-a-stable tools utility, and I'm going to download this thing to one of the nodes because it's not pre-packed yet. In Cassandra 3.0, they have changed the as-a-stable format to be more efficient, so it's in the stage of very high development. Just checking the status of the cluster, if everything is still fine. Cool, it's good. And now we're doing the node tool flush. It does the flush from the mem table to the disk. So we have all our data in the files consistent on the disk. After that, I'm going to download the as-a-stable tools to this node using some wget, for example, app-get install wget. Cool. And now we're just downloading this thing on the system. It should be pretty fast. Cool. Now let's look what's here. Oh, it's so long. Let's rename it to something more less big. Let's move it to just as-a-stable tools.jar. Okay. And now let's actually look into the data directory of Cassandra. We didn't look at it before. Let's navigate to var lib Cassandra. As you see, here is a lot of directories, but we need data. There is a commit log hints that I have already talked about, but we need to go to straight to the data. As you see, here is our experiment key space. We're navigating inside it. And here is the folder of our data. Cool. Let's look inside. So here is 2 files that we can open. They are called ma-1 and ma-2bigdata.db. And we're going to look at them to see what the data looks like inside. Just copy the name of this directory because we would need it to reach the file. And actually, we're going to navigate back to the utility, cd. And we're going to execute the query to JSON, which is called toJSON, to get our table look like JSON to make us see how the data is stored physically. So we're navigating to the Cassandra data directory. Forgot our key space, which is experiments here. Cool. And we're writing the file name of the first file that we can look into. It means that if there are two files, we had two flushes on disk from the main table. OK, there is some exception. Doesn't seem like there was something wrong. Let's just try with the second file. All we're going to do is just copy this and rename the file to the ma-2-big-data.db. And here it is. So here is our partition, which is Albina Street. And we have one coffee shop in this street, which is called Albina Press. And as you see, there is a partition, and the rows are stored as a value of the partition, and the row stores the key value pairs for the columns. And this timestamp is stored. Let's just try again with the first file. I guess it seemed to work normally. Cool. Here is our first file, which has the two entries, two coffee shops from the street, Mississippi. As you see, each row stores the clustering columns, which is the way the partition entries are sorted as. And each row also stores the timestamp for the row. That works. So this may help you to create better queries. That was basically it. And thank you very much for watching this. I'm happy to answer any questions and reach out. Here is my username and my email address. Thank you really much for watching this.